In this video, we'll look at transformations in math called translations, where the translation is represented as a slide of a figure. So if I have a figure and I'm sliding it across the coordinate plane, it means that I can move it up, and paying attention to the vertices, every vertex is going to move up square by square. So we are sliding the figure straight up or straight down. So the figure keeps its orientation, and we can slide it to the right, again up, to the left, up, to the right, down. So when we are sliding the figure, we need to make sure that we use the grid of the coordinate plane. If I have, let's say, the pre-image and the image overlapping, and then I need to translate, meaning slide my figure up 4 units and then to the left 5. That means that I need to go up, straight up, 4, 1, 2, 3, 4, and then to the left, 1, 2, 3, 4, 5. Our problem will tell us what direction to translate the figure and how many units. Left, right, up, down, how many units to the left, how many units up. The shape will always be facing the same way or having the same orientation. So the pre-image and the image will be always having the same orientation. So you can't have, let's say, the pre-image and the image turned around. That it's not a translation. After a translation, the pre-image and image will always have the same orientation. So in other words, if this is my pre-image and the problem says translate 3 units to the right, that'll be 1, 2, 3, and you will end up there, and the orientation will be the same. Or the problem can say translate 7 units down, so you go 1, and then you can keep the vertex 2, 3, pointing straight down, 4, 5, 6, 7, and then you'll end up there. Or the problem may say translate 2 units to the right and then 3 units down. 1, 2, down, 1, 2, 3, and you will end up there. The pre-image and image will always have the same orientation. So if the rhombus is like standing up like this, it is going to stand up like this. You can't have any turns or flips around. So thinking about how the pre-image and image will look like, this could be a translation because the 2 triangles are facing the same direction. This could be a translation. That's a translation, let's say 1, 2, 3, 4, 5, 6 units to the right. So the translation is sliding the figure along the x-axis, along the y-axis, left, right, up, down, using the grid lines. And what we have here in our vocabulary section, that translation is a transformation that slides a figure horizontally along the x-axis and vertically along the y-axis on the coordinate plane, moving every point of the shape same distance in the same direction. So every point of the shape moves same distance in the same exact direction. Let's see how that looks like. If I use my transparency, I'm going to use the pre-image A, B, C, D, and I'm going to follow my motion to get into the image A prime, B prime, C prime, t prime. So from the original ABCD pre-image, I need to end up and see what was the movement. So I need to move to the left and down. So this is where I need to end up. And there we go. 1, 2, 3, 4, 5, 6, 7. So 7 to the left. Let me record that. And then I need to go down. 1, 2, 3. 3 down. So from my pre-image to the image, if I follow vertex A, I had to go left and then turn down, and that is my A prime. So 7 to the left, 3 down. That was the translation. Every time we are translating from left to right and right left, that's along the x-axis, what is going to happen to the coordinates of the points? X value moving to the left, which we had here, will be subtracted by 7. So if I look at the x value of my point 2 and subtract 7, 2 minus 7 is -5. And here is point A prime with the coordinate for x -5. 2 minus 7 units, or moving 7 units to the left, ended up in the x coordinate -5. Then down, if I translate up or down, down means y coordinate, which is the y-axis. So down is along the y-axis. That means that you subtract from the y-coordinates. So here's the y-coordinate 4. Of the pre-image, if I subtract 3, that's 1. When you read the A prime, -5, 1, so the y-coordinate is 1 of your image. Pre-image is the figure before the transformation, or original figure, and then the image is the figure after the transformation, so after our move. In translations, always is important to make sure that the pre-image and image are congruent and have same exact orientation. Why? Because every point of the shape has to go same distance, same direction. So the direction of the shape will remain the same. Let's see a few examples. In example number 1, I have a segment and I need to translate. So translate means slide the segment CD 2 units to the left and 4 units down. In motion, that could be seen using your transparency. If I look at my segment CD and follow the instructions, I have to move my segment 2 units to the left. So when I go to the left, I have to make sure that I go horizontally. Both vertices are going the same direction. So 2 units to the left, 1, 2, and then 4 units down. So now I keep my eyes on the vertices and I make sure that I go straight down along the grid line. So I go 4 units down. 1, 2, 3, 4. And that's where my segments end up. D and C. A segment has to be the same length. C prime, D prime, we label the vertices of the image. So thinking of point D, what happened to point D? 1, 2, to the left, 1, 2, 3, 4, down. Point C, 1, 2, to the left, 1, 2, 3, 4, down. Every point has to move the same number of units in the same direction. So we can do one point at a time, or we can use the transparency to see that in motion. 1, 2, 1, 2, 3, 4. To describe a transformation, we have to identify the pre-image. The pre-image is the original shape, so it has the coordinates or the vertices A, B, C, D. So that's my pre-image. And then the image is after. The image is where we end up. And it's generally marked with primes, A prime or seconds. If it's two transformations, we get to those later. So A prime, B prime, C prime, D prime. So what happened in this transformation? We need to see how the move from A, B, C, D. So I can't go straight across like this. I have to make sure that I go left, right, which I have to go right in this situation because the image is on the right side, so I have to go right and then up. So every time you look at the pre-image, you need to think this is where I start and what I need to be doing in order to end up there. So I have to go right and then up, right and then up. Then you think how much right and how much up. So I'm gonna go square by square, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the right, so I'm gonna say 9 right, just so I don't forget. And then let's see how much up I need to get into that yellow rectangle. 1, 2, 3, 4, and it's a perfect match, so it's gonna be 4 up. So the translation from the pre-image, if moved 9 units to the right and 4 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 4 up, 1, 2, 3, 4, results to the image A prime, B prime, C prime, and D prime. And see how the vertices correspond to the vertices of the image as well. It's important that the image will have the same exact orientation. So the rectangle has the same exact orientation and is the same size. So we can say that to describe the transformation, we say that the rectangle ABCD was translated. The transformation is translation, so it was translated 4 units up and 9 units to the right, or you can say 9 units to the right and 4 units up. The order in which you say that move doesn't really matter. So it was translated 9 units to the right and 4 units up. And when I said that which direction you give first doesn't matter because you're going to end up in the same location, let's try to show that. So if I say the pre-image A, B, C, D was translated 4 units up, so I go 1, 2, 3, 4, and then 9 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm there anyways. So up and right works just fine. Let's see 2 more examples on how to do a translation and how to describe a translation. So to translate a trapezoid ABCD 2 units to the right and 5 units down, I can move every vertex one at a time, or I can use the transparency. So first I'll use my vertices and go to the right 2 units and 5 units down. So starting with A, 1, 2, 1, 2, 3, 4, 5, and label it right away. A prime, B, 1, 2, 1, 2, 3, 4, 5, B prime, C, 1, 2, 1, 2, 3, 4, 5, C prime, and then D, 1, 2, 1, 2, 3, 4, 5. So in a translation, every point has to move the same direction, same number of units. That's what's called translation. We're sliding the figure, same direction, same number of units. If I use a transparency, I can check that A, B, C, D, my vertices transferred over, and then I use the shape to follow the motion. 2 units to the right, so I go 1, 2, that's the move to the right, and then 5 units down. 1, 2, 3, 4, 5. And when you do that motion, you always focus on just one of the vertices, so you can't look at all 4 at the same time. So you just follow one of the points. Which point doesn't matter. So let's say like C here looks like a pointer, so I'll just go 1, 2, and then follow the C, 1, 2, 3, 4, 5, and it's ending up in the A prime, B prime, C prime, which is my image. When given a translation, we need to describe. So I have a transformation done, and I need to describe what happened. So I have ABC, a triangle, which is my pre-image. This means that that was the original triangle, so now I need to figure out what happened to get to the image. So what kind of translation was done, and how many units was it translated? So this is where I need to start, this is where I need to end up, and I can't go again straight across. I have to go up and left, or I can go left and up. So I have to always follow the grid line, focusing on one vertex at a time. And if you choose to go left first, that would be 1, 2, 2 to the left, and then up. So you have 1, 2, 3, and that's where A prime is, 3 up. So if this one was the move, it works if I do it 3 up and 2 to the left. So here's my triangle, and I go up 3, 1, 2, 3, and then 2 to the left, 1, 2, and I end up in the same place. So the transformation was a translation up 3, 2 to the left. So what I can do in my description is say the triangle ABC was, the move is translation. So I can't just say slide, I have to say translated. I need to use the proper movement in geometry or in math. Triangle ABC was translated. And then 3 units up and 2 units to the left. So triangle ABC was translated 3 units up and 2 units to the left. In the translation, again, the pre-image and image have same exact orientation because every point is moving same direction.